Hello everyone, welcome back to another video where we're looking at different beams and how they are loaded, how we go about calculate the reactions of them, and the other nuances surrounding the beam itself. Now in the previous video we looked at a simple centrally located loaded beam. Now we're going to be touching on a offset. So offset. Alright, so this is the offset loaded beam. Now what does this look like? It will look something like this. Say for example I have my beam here, right, and we're going to have our supports on either end. Just keep things simple. We have RL for the left and reaction on the right, RR. And this loaded beam, we're going to offset the load. So I'm going to put the load a bit closer to RL, and we're going to give it a load of 600 units of whatever it is. Now in relation to how far it is away from RL and RR, let us add the dimensions. So let's add the dimensions. Alright, so let's make this one here 5 meters away and this one here 1 meter away to make things simple. Alright, now it means that we now need to determine the reaction at RL and at RR. Now what does this mean? What we're saying is that how much of the total 600 unit load here is RL carrying and how much is RR carrying. Now based on how things look, you know RL is going to be carrying the majority of the load because it is closest to RL. Now a loaded beam or a load of beam, in this case where we have the 600 units, rests on the beam, alright, 1 meters away from RL and 5 meters away from RR. Alright, the diagram that I'm going to be showing you will show you the moment about both supports. So let's see if we can go ahead and do our little calculation. So similar to what we did in the previous example, we're going to write moment. Alright, so we have moment at where RL. Alright, and this is going to be equal to the 600 multiplied by the distance that it is away from RL, which is 1 meter, and this will give us a value of 600. 1 times 600 is 600. Alright, so now that we know that value, let's now determine the moment and the moment at RR, and this is going to be equal to, it's going to be equal to RR multiplied by the total distance between the two reaction points, which in this case is 5 plus 1, which is going to be equal to 6. Alright, which is going to be equal to the value that we have here, which is the 600. And again, we need to make RR the subject. So how do we do this? We're going to say RR is equal to 600, alright, divided by 6, and that will give us a value of 100. Alright, so that's the value that we have there. So it means that the reaction at RR will be equal to 100. Alright, and to determine what RL is going to be, we simply take that total value. Alright, so let's see if we can do that now. So we have 600, alright, minus the 100. Guess what is going to happen? How much is remaining? 500. So it means that RL is carrying 500 units of the total load. Alright, so this is how we go about determining it whenever we have a offset or uneven loaded beam. Alright, now if you found this video helpful, don't forget to go ahead, leave a like, share and subscribe, and if you're in need of any lessons, feel free to reach out to me. See you in the next one.